Good morning, guys. So I hope you understood the portion till where we have stopped. We stopped with the topic propagation of errors. So till that portion, the error portion, that is error section, is completed. So please understand the topic by listening to the video again and again until you are thorough with that topic. It will be very difficult to do the numerical questions. And let me tell you guys, from error section, lot of NEET questions as well as CBSE board questions, right? Board questions in the sense your 11th exams portions, it gives a high weightage from that side. So let's move on to the next topic, which is significant figures, which is very easy, guys. Significant figures. Actually, you have done these things in your life. It is rounding off, etc. So significant figures, or you can say significant digits. Significant means the digit which is important, which are not important, right? So why we are using the significant figures means, say this usually I just tell you for rounding off the figures. That is, you will have a number, right? It might be a non-terminating number. So what you will do, you will either write a dash over the last digit, or you will stop with some number and you will just round it off. You do it in your daily life. Let's say someone says that his salary is 55,000, right? So does it mean that he gets exactly 55,000? That is 555,000,000? No, he might be getting amount 55, 256, like that, right? So he just round it off, and it's a common sense, right? It doesn't matter which happens. That he just says that I get salary of 55,000. Or if he says that initially my salary was 44, doesn't mean that he's getting 44,000 exactly. It might be 44,000 something, right? So this is the process known as rounding off. That means in this number, this 256, that is the last three digits, are not significant. Clear? Right. So I hope you understood this section. Right, my phone was not in silent, that's why that sound came off, guys. I just turned it into silent mode, then it's okay. Right, so this is the daily thing which you have done, or which you have heard about it, right? At the same time, you would have done that. Suppose you get an average marks of 77.89, you will not say that I got a percentage of 77.89. You will say how much percentage you got. You will say I got 78% of marks, right? That is known as rounding off. So similarly, I have to understand which all numbers are significant as per me and which are not significant, right? So similarly, if you are having different units, say 4 kilometer, right? This is the same as that of 4,000 meter, right? So 4 kilometer, it might be 4.2 kilometers, 4.3 kilometers, right? So when I convert into the meters, I will not be writing the exact numbers. I just round it off to 4,000 meters. It might be 4,236, 356, like that, right? So we round it off. The last three digits we removed, and I told that the 4 kilometers around 4,000 meters. Right, 4 kilometers, it might not be the actual distance, might not be 4 kilometers, it might be 4.3. That is, will be some distance, right? Because suppose you are giving direction to a person, the distance you have to travel is around 3 kilometers, right? That is around, right? So there also unit conversion also, you might not be giving the exact meter conversion or exact value. You just give an word, a roundabout way. So these and all things, if you have to do, then you have to know which and all figures are significant, which and all figures are not significant. Right? You want to round off to 2 digits of significant figures or 3 digits of significant figures. So you have to know what are significant figures, right? So that's what we are going to do. And for that, there are some rules. Right, so I will not be writing the explicit rules like this, like a stretch. I will take each rules and then I give you some examples. Okay, so the first rule is all non-zero digits are significant. It's very easy. That is, all the non-zero means numbers or digits which are other than zeros are significant. Say if they are having a number 3.14, is there any zeros? No. So 3 is significant, 1 is significant, 4 is significant. These two 4s are. So how many significant figures does it have? It has 4 significant figures. This one, this one, this one, and this one. Very easy. Similarly, see 3.1. How many significant figures does it have? 1 and 2. It has 2 significant figures. Similarly, 2.123, how many significant figures are there? 1, 2, and 3, and 4. So there are 4 significant figures. Very easy. The first rule is very easy, guys. All non-zero digits are significant. Now the second rule is all zeros between 2. In your textbook it is non-zero, but I will say along with non-zero write it as significant. Digits are significant. That is, between two non-zero numbers or two significant digits, if there are zeros, then it is significant. I hope you don't understand. Let's say an example, 403. Just previously we said that all the digits which are not zero are significant, right? So that means zeros are insignificant as per the first rule? No, there are also zeros also. There is a particular rules regarding it. If 0 is between 2, right? So this 0 is between two significant figures, or I can say non-zero numbers. This is for non-zero, this is non-zero. So this 0 which is between two non-zero numbers or between two significant digits is significant. So this 0 is also significant. So how many significants are there in 403? 1, 2 and 3. So it has 3 significant figures. Now similarly 2001. Right, these two zeros are between, right, if you have problem, let's say, let's consider only this 0, right, let's say this zeros, right, so you will have confusion that this 0 is between this and this. I don't know this if this 0 is significant or not, so we'll take this as a 2 package, right. Both these zeros are between two significant figures, 2 and 1, so this double zeros are also significant. So this entire digit has entire number has 4 significant figures. Easy, right? So that's 2 rules are very easy. Now let's move on to the third rule, that is ending zeros. This is the case with ending zeros, right? Ending zeros are not significant unless decimal is present. In a decimal number, all the ending zeros, right, decimals should be there and the ending zeros are significant. I hope you didn't understand, guys. I'll give you an example for it. Let's say 2.40. So let's say if this is an ending zero, yes, it is an ending zero. Is there a decimal? Yes. So after decimal, the right of the decimal, right? This is decimal point right. And this 0 is at what? End. So that 0 is significant. Ending 0 after decimal is significant. So this 0 is significant. So how many significant figures are there? 1, 2 and 3. So there are 3 significant figures in 2.40. Let's say about 3,000. How many significant figures are there? Let's say this 3 is significant, that I am sure, right? After decimal, right? These 2 zeros are not ending zeros. Let's say like that. This 0 is ending number? Yes. This 0 is ending digit. So these 2 are significant. This one, first and the last, according to the rule. Now what happens between these 2 zeros? That is according to the second rule. All the zeros between two significant digits. This 3 is significant. This 0 is significant. Then these 2 zeros are also significant by it is between two significant figures. All the zeros are significant. So how many significant figures are there here? 4. Clear? Right. Now similarly, let's take it as 2.300. Right. 2 is significant, 3 is significant, this last digit or 0, that is after decimal, the end 0 is significant. So and then this 0 is between two significant figures, that is 3 and 0. So this is also significant. So again, 4 significant figures. Alright, so now let's take 420. There is no decimal point, right? So this 0 is not after what? Decimal point. So this 0 is not significant. But 4 and 2 are significant figures. So how many significant figures are there? 2. Clear? I know I'm taking it in a fast pace. Pause the videos, guys, or pause the video and listen to it again and again. Then it will be very understandable. Clear? Now, fourth rule. It says regarding initial 0. The earlier was ending 0. So now we'll deal with what? Initial zeros. Starting zeros, you can say it like that. Right? How can I say whether it is significant or not? All the initial figures or zeros are insignificant. That is, say 0.0042. How many significant figures does this number have? This 0, as per this rule, there is an initial 0, it is not significant. Right. Now let's say about these two zeros. These two zeros are between 4 and this 0. Right. This 4 is significant, but this 0 is not significant. That means these two zeros are not significant. Right. So how many zeros are insignificant? These 3 initial zeros are insignificant. So that means only 4 and 2 are significant. So how many significant figures does it have? It has 2 significant figures. Clear? Let's say another example, 0.1020. Right. This is an initial 0, not significant. But this 0 is between 1 and 2 is significant. This 0 is the ending 0, right? Ending 0, remember? Ending 0 after the decimal point. This is a significant number. This 2 is significant, this 1 is significant. That means this number has 4 significant digits or significant figure. Clear? Right. So let's move on to the fifth rule. And how many 6 rules are there? Actually, guys, this is not the way in which the textbook is written. Some other wordings are done, but the rules are all same. Okay, so I'm taking as the simplest form so that it will be very easy to you guys to understand. So the fifth rule is power of 10. Right. So power of 10 are all insignificant. Right, that is, say 2.4 into 10 to power 6. Out of this 10 to power 6 is the power of 10, right? So this power of 10 is not significant. So only 2 and 4 are significant, hence the number of significant figures is 2. Clear? Now 3.0 into 10 to power 7. 10 to power 7, 10 to the power number is insignificant. So this 10 to power 7 goes off. So this 3 is significant and this 0 is ending 0 after decimal point. So it's also significant. So how many significant figures are there in 3.0 into 10 to power 7? 2 significant figures are there. Clear? Now the last rule which you have to deal, that is 6th rule, is pure number or constants. All the pure number. Constants means values which are already been declared and there is no change in that number, are having infinite significant numbers. Let us say Avogadro number. It's a constant, right? Sorry, spelling wrong. Avogadro number, right? Say, so it has a constant value, so it has infinite amount of significant figures. Pi, right? 22 by 7. Even if you can find the decimal values, pi is a constant value, it's a constant section, so it has infinite number of significant figures. Refractive index of any material, say water is having 1.5, so that means 3 by 2. That means it's a fixed number, right? So then you will say it has 2 significant figures. No, it's a constant value. So it has infinite number of significant figures. Similarly, someone says, yes, I have 6 bananas with me. Right? It's a constant value, right? Have given you constant amount, right? So it means how many digits or how many significant digits it has infinite amount. Clear? I hope this much is clear. Then after that we will do a lot of I will do some of the examples, guys, so that after writing the examples numbers, I will wait or not wait, you guys can pause the video and try to find the answer. So first I will write the digits, then only I will go for the solution. Okay, so this side like this I will make around I will take 6 or 7 examples. It will be consisting of all the points which we discussed. Then you guys have to pause the video, write the questions on your paper, write the answers by yourself, then unpause the video and check whether you have got the exact same as that of the answers I have written. Okay, now write down the example, guys. 2.43 as plus 1, 0.020, 2.341, 2.10 into 10 to the power 6, 0.0123, 0.004200, 26001, 31.00, 120, 130 into 10 to the power 3. So the numbers, right, pause the videos, write the numbers, then write the significant number as you know. So I hope you have found the answers. This 3 non-digit 0 numbers, so it is having 3 significant numbers. Here this is an initial significant number 0, so and this is also between 2, one is non-significant, this is significant, so this is also not significant, this is also not significant, this is trailing 0 or ending 0, it is significant, this is significant. So this number has how many significant numbers? 2. 2.341 non-zero numbers, 4 significant numbers. Here 10 to the power number doesn't mean it is not considered as significant figure. This 0 is a trailing 0 or ending 0 after decimal. Significant, significant, significant. 3 significant figures for this question. 0.0123, 0 initial, 0 between non-significant and significant. So not significant, not significant. 1, 2, 3 is significant. So 3 significant figures. Now again these 3 zeros are not significant. 4, 2 significant. Ending digits after decimal is significant. So there are 4 significant figures in this question. Now 26001, these 2 zeros are between 2 significant figures. So this is also significant, this is also significant. 2, 6 and 1 are significant because they are non-zero digits. So 1, 2, 3, 4, 5. So 5 significant numbers here. 31.00, these 2 are significant, these 2 are trailing zeros. So there are 4 significant figures here. Next question is 120, no decimal values. So this 0 is not after decimal, so this is not significant. 1 and 2 are significant, so 2 significant figures in this question. And the last one, 130 to 10 to the power 3, 10 to the power 3 is not significant, whereas 130 is 1 and 3 are significant, whereas 0 is not after decimal points, so this is not significant. So there are 2 significant figures in this number. Yeah, I will be sending the homework with the same section, guys, so it will be very easy to do. Alright, the next section which we are going to deal with is rounding off. Okay, rounding off, the questions will be round off this number to the closest 2 significant figures. That is, the answer should have 2 or 3 as per the question. You have to reduce them into 2 digits or 3 digits. So the first rule is, if you are having a number which is ending with a digit which is less than 5, then leave the number as it is. If it is greater than y, add 1. I hope you didn't understand. We'll do some question, guys. See, we'll first do with rounding off to 2 significant figures. Right, let's say 2.43. How many significant figures this question has? 3 significant figures, and you are asked to round it off to 2 digits. That is, the answer should have only how many significant figures? 2. So this, let's say this is the last number. Let's say if it is greater than or less than 5, it is less than 5. So that means just remove the last digit, do nothing. So it will be what? 2.4 is the answer. That is rounding off to the 2 significant figures. I have round off this 2.43 to 2.4. Right. See, let's take another example. If this is 2.48. 8 is the last number. Is it less than 5 or greater than 5? It is greater than 5. That means you are asked to add 1 to which number? To this previous number. To add number 1 to 4. So the answer will be 2.5. Right? I hope you understood. If the last digit is less than 5, you keep the number as it is. Right? 2.4 is kept as it is. If it is greater than 5, add 1 to the digit. That is, add 1 to 4. Not to 8, guys. To the 4. Clear? Right? I hope you understood this much section. Right? So that means you have to understand, look into the digits. The problem comes if the last digit itself is 5. Right? So what would you do if the last digit is 5? So listen guys, let's do an example. So there are two rules for it. And the last digit is 5. Last digit in 5 in sense, if there is any, suppose, let's take the simplest one, then we'll go for the complicated stuff. Hope you understood the rounding of figures when it's less than 5 and greater than 5, right? Now we'll move on with if it is 5. Suppose, say, this is a number 2.25, right? And let's say it is 2.75, right? The question is, how do you round these two figures to the closest to two numbers, significant figures? So you always look at this number, this is 5. If it had been less than 5, you would keep it as it is. If it is greater than 5, you would add 1 to the previous digit, right? So now what happens if the last digit is 5? So there is a rule. When you look at this number which is ending with 5, always look at its previous number. If it is even, this is even, 7 is odd, right? Even number means leave as it is, so the answer will be just 2.2. If it is odd, means add 1 to the previous number, the answer will be 2.8. I hope you understood. Even, leave as it is. Odd, add 1 to it. Here, let's do a simple example like this. Let's say 2.73458. Right, how would you round it off? It's very easy, guys. 8, right? 8 means you can do it as it is, but I am telling you the proper way. 8 greater than 5, add 1 to this one, so it becomes 6. Greater than 5, add 1 to this, becomes 2.735. Right, now comes the problem. 5, so this is an odd number, that means add 1 to it, so it becomes 2.74. Now 4 is less than 5, so the answer is 2.7. This much is clear, right? Right? Happy? So let's move on. This is how you are rounding off to 2 0. This and all, when I'm telling it happens fast because I know how to do it. Right? So while you guys are doing it, take time for the first few steps. Right? Now let's say it's similar. This was rounding off to 2 digits. Suppose it is 3 digits. It is 0.04234. You are asked to round this number to 3 significant figures. How many? 3 significant figures. So in this question, how many significants are there in this question? These 2 zeros are not significant, right? Initial zeros. These 4 numbers are significant. So actually there are 4 significant figures. You are asked to reduce to 3 significant. So again, look at the last digit 4. It is less than 5. So keep the number as it is, rest of them. So it becomes 0.0423. That is answer. So there are only 3 significant figures. Easy. Right. Now next is 2.345. Right. Again, look at the 4. Before it is an even number, so leave it as it is. So it becomes 2.34. 3 significant figures. Initially there were 4 significant figures. Clear? Next one, 3.1352. 2. Not significant because we are rounding off, right? So next it becomes what? 3.35. So before 5, just 3 odd means you have to add, so it becomes 3.14. Clear? Right. I hope this much is clear. Similarly, let's do 1.723. You can directly write 3 is a less than 5 number, so it becomes 1.12. I hope easy peasy. Now there is a section called multiplication and division rules, girls. actually it is addition and subtraction first we have to do, but it is very easy to understand the rule of multiplication and division. That is, when you are adding two numbers or when you are multiplying two numbers, two or more numbers, you will get a result. So it might be having a lot of numbers, digits. So what is the rule of how many digits you are actually supposed to write? That is the rule for multiplication and division with respect to significant figures. Suppose you are considering first multiplication and division, guys. So you are taking example 6.4 into 0.2. Its actual answer is 1.28, guys. Please do the multiplication. Right. So here there are two significant figures. Here there are only one significant figures. But how many do you see in your answer? There are three. Right. So as per rule, when you are doing multiplication, the answer should have the number of significant figures as with its multiplicants. After the multiplicants which is having the least value, that much significant figures only the answer should have. Listen properly. The answer should have the number of significant figures equal to the number of significant figures of the multiplicand which has the least one of them. See, you are having here 2, here 1 and 3, right? So this answer should have only the least number of significant figures of its multiplicand. Out of its multiplicand, which one has the least significant figure? This one. So this much means this one is having how many answer or how many significant figures? 1. So the answer should also have only one significant figure. So that means you have to round this value. So it becomes 8, right? 8 is greater than 5, so it becomes 1.3. Again, there are two significant figures. 3 is less than 5, so you leave it, so it becomes 1. So 1 is the value, or 1 should be the answer written, because 1 now has how many significant figures? One significant figure, same as that of the multiplicand with the least significant figure as this one. Clear? Now let's take another example. 36.48 divided by 12. You will get the answer as 3.04. Please do the division, guys, by yourself. Right. This one has 4 significant figure. This one has 2 significant figures. So the answer should have the same number of significant figures as that of the least one. So this least one is this one. So how many significant figures does it have? 2, right? So the answer should also have only 2 significant figures. So the answer is 4 is less than 5. So you leave the number as it is. So it is 3.0. Clear? I hope you understood. Now the last section is addition or subtraction. So that one is a little bit different, guys. Suppose I have two numbers, 2.42 and 1. Let's take three numbers, 0.2. Right? How would you add? You will add like this: 2.42, 1.32 and 0.2. Add it 4, 7, 9 and 3. Right? 3.94 is the actual answer mathematically. But as per significant figures, as per the rule for addition and subtraction, the answers after decimal point, right? After decimal point of these numbers, out of these three numbers, this number has the least significant number, right? After decimal point. After decimal point, this one has 1, this one has 2, this one has 2, right? So the answer should also have this much least significant figure only. So after decimal point, there should be only one significant figure. So that means it will be 3.9, because 4 is less than 5. Leave it as it is. Clear? So always look for not the number which has the least significant figures, just like that of multiplication and division. Look for the number which has least significant figure after the decimal point, not with the previous one. Right? Let's take another example. I will compare two digits. 6.2 I am going to multiply. 6.2 I am going to add with 0.12. When you multiply, you will get an answer of 0.744. Right? So 0.744, when you compare these two numbers, this has 2 significant figures, this has 3 significant figures. So in multiplication, the product should have the same significant figures as that of the least significant as a total. This one has the least significant figures, that is 2. So the answer should also have 2 significant figures. So it will be 0.7. how much? It's 2 significant figures, right? So 0.7, this 0, 4, right? This 0 is not significant, right? So 0 is 0.74. Clear? When you are adding 6.2, 0.12 will be 6.32, right? So look for the digit or look for the number which has least significant figure after decimal, right? After decimal, this one has the least significant figure. So this one also has to have only one significant figure after decimal point. So answer will be 6.3. Clear?